talk about mobility challenge with AI, and I'll let you the floor for you, Félicie.
Thank you, Alexandre. Thank you for this nice challenge. Thank you, and good morning, everybody, again. I take the opportunity to welcome those connected to our LinkedIn account and to join me in discussing the challenge of AI within mobility. So, to start, please take a look at this picture. And what do you see? You see two different pictures, obviously, two different worlds, and in between them, 140 years. 140 years in between what you have on the left side, which is one of the first Peugeot vehicle in 1880, and on the right side, what is Zoox, which is Amazon robotaxi. So 140 years, two different worlds, a world apart, a lot of years of, obviously, innovation, but also change in the way we move, a change in mobility. Because our industry for years, decades, has been pushed by mechanical engineering mainly, and a lot about heavy industry. And today, we are really in the middle of a big transformation where AI obviously is playing a key role. Today, when we talk about AI in mobility, usually we think the first things that come to mind is self-driving vehicle, right? But there are many other applications beyond automotive driving, autonomous driving. And today, market players are really using AI in many different ways to enhance, in multiple ways, their operation and their product. So, as I said earlier, yes, it's true that this is something quite new. This is something quite powerful, and we don't fully understand yet the potential and the impact of it. But like any new big innovation, it's here now. Some people are already using it. So there is no way back to the way it was before, the way we were doing things before. So it's a new paradigm, it's a new dimension that we are entering. And probably this new revolution that we are entering will have an even bigger leap forward in the future. It's also true that we say a lot about AI, that it's both a blessing, but it's also potentially a burden in terms of all the collective efforts that we are doing in sustainability, because a blessing, because it gives potential access to new things that we could never do before. And when we think about that, obviously, we think about medical science. But also to do that, we need more energy. So there's a challenge here. But I really think that it's, at the end of the day, it's up to us to make the most of this new innovation. It's really the key ally for us to tackle the global challenges that we have in our industry, in mobility industry. And it is the one key lever that we can activate to drive this new generation of mobility, one that we want to be safer, more affordable, and more sustainable. So it is my responsibility, your responsibility as business leaders to really identify what is the potential that you can use to bring to your own organization so that it brings more competitiveness on one side, but also obviously it enables you to differentiate yourself from your competition. So when we think about OPmobility, for me, there are three dimensions in which AI is having an impact. The first dimension is what I would call the everyday AI. AI that you use in your day-to-day activity. AI that enables you and me to really improve your own productivity. So generating automatic minute meetings, planification of your meetings, expense report, all of that. So all of that low-added task that you want to take out of your plate. So that is what I call the augmented employee, you and I. Then there is a second dimension. Here, for me, it's more about how do we rethink, reshape the way we work, the way we process things. And here, again, it's about how being more optimum in the way we work, more efficient. So, and that can apply to many different fields within your organization. It can be R&D, manufacturing, finance, supply chain, all of that to be more efficient. This is what I call the augmented engineering. And the third dimension, and probably the most disruptive, it's about coming up with new services and products. Here, obviously, AI has totally changed the way we interact with the car and how the car is interacting with its environment. And that has created many new tools and applications, and consequently, potentially, new products and services. So this is what I call the augmented product. And today, when we talk about augmented products for consumers like you and I, usually we are speaking about self-driving vehicles, obviously, but also infotainment system and all of what is linked to predictive maintenance and full life cycle services that you can get through the life of your vehicle. So let me give you 3 very quick examples of today what AI already makes possible. First, it makes possible to drive more safely because the enhanced perception around the car is providing the car the opportunity to detect more complex objects, human, detect some more dangerous situation, and prevent accidents. Secondly, it already makes it possible that your car is your best intelligent companion because the car anticipates your needs, know what is the music you're listening to currently, so which is the one you want to hear when you get in your car. And also, the car think about, if you want to drop by Starbucks before coming here, what is the best route for you to be on time and not miss my great keynote. And the third and that will keep on increasing as the car keeps on getting more and more connected to the city and to your home. And the third example is obviously what it makes possible is to have a more sustainable driving because it can analyze the density of the traffic, and depending on how is your driving mode and how efficient you have to be when you are, for instance, managing a fleet, to make sure that you are on time and you optimize your fuel consumption. So all of that is already possible and accessible. So again, 140 years in between the 2 first pictures. So the question obviously is, how will it be in 140 years? That, unfortunately, I don't have the answer yet. But what is for sure that a lot is happening. What is for sure is that there is this concept of smartphone on wheel. So obviously, cars today are not smartphones, at least yet. But there is this idea that technology and connectivity has to be seamlessly integrated into one single object that provides you and me with this great experience that you are having with your phone, right? So we want to have that. And that is why today, almost half of the people that are about to buy a car are considering the CarPlay and the Android Auto as a key decision criteria when buying a car, because they don't want to have the one of the OEM. They want to have the one of Apple or Android. And that is why there are so many big tech companies and electronics companies that are investing so much, billions of dollars, in AI in mobility. So something is happening, and the pace of that is accelerating. So acceleration, speed. This is posing a challenge for our industry. And that is why I'd like to share what I think is the most specific characteristic of artificial intelligence is speed, acceleration, timing. You will hear a lot about that throughout of the day. Because today, our customers, the car makers, one of their key challenge is to reduce the time they need to develop their vehicle. Because software on one side and electrification on the other is imposing a new pace of innovation because of processors and digital offering that are having a faster pace. So if they want to have a car that is not outdated when it hits the dealership, they need to reduce this time of development phase. You have on this slide a good summary of how is the situation today, of the time needed for a car maker before entering into production. So you can see that new players, so most of them EV players, they need 20 months in average, so which is less than 2 years. While the rest of the industry used to have, now they're obviously pushing more to the 20 months, used to have an average of 40 months, so double the time. Imagine what can be the change in technology in almost 2 years. They have to reduce the time. How do they do that? Obviously, AI is not the single answer. They also apply good enough practices, meaning revisiting the way the processes, because our industry has this tendency to, over-engineer processes. So they just decide, okay, that's good enough. I won't do apply the full book. And on top of it, they apply AI systems on the simulation tools that our industry has been using already for decades. And they apply that on the conception, the design phase, but also on the certification phase. If we take the example of design, here, we have this new activity, H2Power, which is dealing with a storage system for hydrogen. Here we have used AI to find the most optimized layout and assembly process to have those vessels embarking as much hydrogen as possible. But obviously, you can also use AI in testing, prototyping, certification, because today, having the capacity to simulate how this object behave in different conditions, in different ambience, and matching that with different criteria, obviously you can also anticipate even failures that you won't be able to detect in the real world. And obviously also it prevents you from doing the actual physical testing and prototyping, so it's more sustainable. So you can use AI on a lot in design and development phase, but you can also use AI in the manufacturing phase. Actually, AI is one of the big driving force behind what we call Industry 4.0. So there are a lot of topics, but the big ones are, putting robots during the production line to optimize the production process and the flows. It's about putting robots and machines to detect and trace potential defaults. And it's about predictive maintenance to avoid machine failures within your plant. And here, it's another example of what we have done, still for our H2 power activity, which was new. So we had to come up with a new plant concept, compact plant process, and we did a digital twin of what would be the perfect plant for us before starting from scratch and try to anticipate as many problems ahead of constructing those new sites. So I hope by now you will have understand that it's a lot about how to save time, how to be more efficient, how to be fast, because at least me, we could all enjoy a bit of more time and focus on task and thinking about what are all the great things and strategic topics that we all need to tackle. Now, I wanted to take the opportunity of this keynote. Obviously, what OPmobility does, it's designing and producing components and systems. And for the reason that I've explained before, it's really a hot topic for our industry. I wanted to focus and deep dive on the R&D topic. And for that, I would like to call on stage Nicolas LESEUR from 𝗟𝗏𝗪𝗀𝗃𝗃, who's helping, working in a startup. Welcome, Nicolas.
Thank you, Félicie.
Working in a startup that is already helping us on various topics. The purpose of 𝗟𝗏𝗪𝗃𝗃 is really to provide companies like us with the tool to have the AI expertise and gain, but without giving away the knowledge to third party.
It's a big topic.
Yeah?
Can I play with this?
Yeah, sure.
All right. Thank you, Félicie.
The floor is yours.
Thank you very much. Good morning, everyone. Good morning, LinkedIn and YouTube. So very happy to be here. Great opportunity from OPmobility to give us this stage today. You're probably wondering why we're going to talk about the Little Prince. I'm going to get there in a moment. First, maybe a quick introduction. We've been working together for about 3 years with OPmobility, between 𝗟𝗏𝗪𝗃𝗃 and OPmobility. And 𝗟𝗏𝗪𝗃𝗃 was founded in 2018 in Lausanne, in Switzerland. And with the simple idea that we should empower designers, engineers with the tools so that they can achieve their dream designs. And practically, what does this sort of mean? That we give the tools to engineers so that they can create, train and maintain and own their AI model. And we're going to touch about this and talk about this quite at length during this keynote. Maybe what I want to say is that the product itself of 𝗟𝗏𝗪𝗃𝗃 has evolved a lot over the last 5-6 years and over the course of the collaboration we had with OPmobility, from 3D Gen AI that we started with like 5 years ago, and all this like 3D sort of type of AI surrogate modeling that everyone talks about. But we gradually realized that the value was beyond those 3D AI models, and we started to design a modular platform that helps orchestrating all the latest technology bricks that you have available on the market. So I think on this, where we bring the most value, and you briefly touched upon this today, that we really see ourselves as a catalyst or of a PLM or an accelerator of product development. And now we talked about who we are really quickly. I want to get to this picture and talk about the vision. And I think the vision, we all share the same vision. It's about autonomous industrial processes and design. But to get there, there's all kinds of different hurdles, right? And we see probably one major type of hurdle. This is the nature of the fragmented nature of the industry. May this be on the technology side. So even though we know that there's been recent M&A, acquisition and things in the space of CAE, CAD, PLM, we'll still have, a couple of key players, technology providers, with limited interoperability. So that's one part of the fragmentation of the market. The other fragmentation is the silos that everyone knows about when it comes to the interactions between a designer, a simulation engineer, the regulation parts, the manufacturing. Right. So the interaction there, again, there may be some room for improvement. So the question is, now we've developed this modular type of technology, we feel that we're in a position that the momentum is such that within the next 10 to 20 years, we could think along the lines of this little prince that once thought to ask someone else to draw a famous animal, but then ask a Gen AI to literally draw a product, draw a car. And that's a bit why we picked this up here today. So I think now we understood the vision. There's still some learnings or some challenges to get there. And I think we can learn from how the market capitalization have shifted from big industrialist player. Then you can see, I hope you can see the GMs and the Toyotas in the 80s and the 90s, all the ways to more software-oriented companies. And I guess you can recognize all of those. There might be an exception, which is Saudi Aramco, but you know why. But if I had to, the very interesting thing is that this plot was made in June 2024. If I had to put Tesla on this, now it would be at $900 billion of market cap. So it would actually be in the top 10 of this plot. What matters is that companies like Tesla, like BYD, like Joby, and those type of companies understood that by infusing those type of softwares into hardware, they could capture and create, a market value that is way beyond a hardware-only type of approach. And the cherry on top is that, of course, you can tick all the boxes of the traditional metrics of what clients want, as technology providers: cost, quality, sustainability, service, innovation. But the cherry on top is that by infusing software into your hardware practices, you can also gain a new type of competitive advantage that you highlighted. It's the need for speed. Yeah. And I think that's really the next level of competitive advantage that AI can also help us to gain and help OPmobility to gain.
Okay. And so this is very valuable to us, obviously, but we started touching upon know-how. It's like us when we are telling our OP colleagues, you can't use ChatGPT and give away information on OP. So we need to make sure that we are not giving away the knowledge and the IP. How do we make sure that is not happening?
Yeah, that's a tricky topic. Yeah, that's so the way we would see this, and I think a couple of decades ago we realized that intellectual property, know-how, could be not only captured in the shape of patents, not only captured in the shape of hand drawings type of know-how, but also in the shape of a CAD, a late 70s, or CAE, Nastran in 79. With 𝗙𝗏𝗃 AutoCAD. So gradually we realized that know-how could be also captured in a digital form. Yeah, and that's, I think everyone is aware of this. We also understood it can be captured in the shape of workflows with CAE. But what we also gradually realize is that the next level of IP capture or IP encapsulation, know-how encapsulation, will be AI models. AI models are basically predictors, universal predictors, that try to mimic, depending on the definitions, some of the human tasks. And the challenge then is, if we accept that know-how may be captured in the shape of AI model, then whoever owns those AI model, whoever trained those AI model, may actually maybe lead or govern your company. And that's, I think, something that we should be very sensitive about. And that's why we think that one of the major challenges is to give companies the right tools to capture, to create and train their own AI models, just the same way we see here. Another important point that you see on this picture, and we're going to get there, is that we don't think that there is a one-size-fits-all type of AI model. There is a constellation of AI model that will be as specialized as human beings or human experts. So it's more about a constellation of AI experts that we're going into, the direction that we feel that we're going into, rather than a big one black box universal model that may solve it all. And I think that's also leave the space for a new type of role for engineers, such as AI coordinator. But I think we're going to talk about this.
Yeah. So indeed, engineers here will be the agent of change. That raises a lot of questions. We're back to this concept of augmented engineer I was talking earlier. Basically, they will not be running their own simulation, but they will use AI. So it poses two questions for us as a company. It's how do we make sure we train our engineers to actually be able to do it? And how do we make sure we have the right level of data? So which means putting in place data governance, taxonomy, and all of that into place.
That's right. So on the skills side, I know this is a favorite topic of many people to know what's going to happen with my job and things. But we see, and I hope I'll be able to demonstrate this to you, we see just plentiful of opportunity for the job of engineer to be completely reinvented. And so I think I really love this picture of draftsman here, because I think I don't know any designer nowadays who would love going back to a time when you have to measure distances and angle. I don't know any simulation engineer who would love going back to a time when you use an abacus to know whether maybe you manually converge towards a solution. So if we take this analogy and move 20 years from now, in 2040, do you think that engineers will enjoy changing their little meshes on their design or iterating boundary conditions to find the best performance? We don't think so, yeah? But we think that those tasks will be automated or handed over, delegated to AI models. But there will be rooms for the AI, the engineer job to move in 3 different directions. One, we touched upon this, it's a form of AI orchestrator, yeah, or a command center sort of director of a constellation of specialized AI model. 2, it's the trend that we see nowadays, I mean, that's been on and on, more and more complex products. Typically, we feel that we'll embrace more of an era of co-design. Practically, you can design a cold plate at the same time you design an EV battery, at the same time you design the housing, all at once. Something which is very tricky nowadays, but we can imagine that this will happen in the next few years. So more, complex type of designs, processes, and material to be considered. And the third one, that's concretely, AI lowers the cost of prediction on the market. But if a good, value of a good diminishes, then the complementary goods increases. So the skill set of engineers will also move away from their prediction type of tasks and embrace other tasks such as stakeholder management, failure mode checker, sometimes AI may fail, more on the, maybe focusing on the quality of the data that is being acquired or on the testing. So we see plentiful of opportunities for the role of engineers to keep evolving in the future. Maybe one last point is also from a data science tech stack standpoint, the tools of data science required for engineering are quite different from the one for e-commerce or finance. And this is also why training in engineers is a significant investment for most companies. A senior engineer would be 10 years of experience minimum. And this is why a different type of tech stack than just a set of Jupyter notebook, is required to handle the complexity of 3D things moving in time. And I think this, we hope that I give you a bit some hope of how we can reinvent the world or the job of engineers in the future.
So maybe let's take 2 concrete examples on how you've been helping us. The first one, so we are the worldwide leader in producing fuel tanks. We produce 19 millions of them each year. And there is this challenge that when you are accelerating and braking, sometimes you can hear the noise of the petrol within the tank. While it's a mechanical problem, there's an AI solution to it.
Right. So we worked on this problem. It was one of the first problems we tried to crack with OPmobility. It was with the team of 𝗙𝗶𝗰𝗶 𝗕𝗂𝗏. So this is the case of how you can try and predict the noise and ultimately reduce the noise that a tank is, or the fuel in the tank is making under a multitude of things. So it's maybe different motions, different accelerations, different types of tanks, as you can see on these animations, different orientations of tanks, different filling levels of tanks. So you need to account for up to 28 different types of tanks. Some of the bottleneck we see nowadays is that simulation to get this acoustic spectrum you see here takes about 12 hours, average time. While we've got rather complex physics happening, acoustics, mechanics, and these things, the aim of the game is rather simple. It's whether or not it's below or above a 50 decibel threshold. Above noisy, below quiet. And in this very case that we work with OPmobility, we managed after some time as part of the project to reduce the number of recalls, so noisy tanks by 20% over the course of 1 year. And so this project is now wrapped up in the shape of an API that is ready to go to prod next year into the one-click system that OPmobility is developing or is owning. The second example.
Second example, so we are also worldwide leader in producing exterior parts. So we produce 24 million of bumpers, but we produce also 2 million of tailgates each year. And on tailgates, you've been helping us to tackle the deformation of the part.
So that's, thank you. That's a work with the team of 𝗟𝗩𝗘𝗲𝗍 in Lyon. And so here you see all kinds of different shapes. Yeah. So typically those are the ones that you would upload, yeah, on the web app. And then you get a 3D field of how it's going to get deformed once it's completely cooled down. And here the aim of the game is to find those set of process parameters. Where should I inject? How much should I inject? What type of material? Which temperature? Which velocity? And maybe help the designer to know where should I patch and reinforce this tailgate so that the deformation is minimized once it's cooled down. It's quite of a complex approach, as you can sense. We're talking about hundreds of thousands of nodes. There are different types of materials, different types of injections, but in the end, it really provides here again an instant feedback to the designer so that they can know where to sort of reinforce the tailgate, and prevents those sort of lengthy iteration cycles between designers and simulation engineers. This is here a web app. It's ready to go to prod next year, Q1.
Thank you, Nicolas. So as you can see, AI is already there. It's already happening. Obviously, there's still a lot of potential, a lot of hurdles to be tackled, and we will discuss that in the panel this afternoon. But it's really now time to embrace this whole transformation. It's time for us to also sort what is the hype from what is the reality of it, and to really have open eyes on what is the full potential of it for us. So it's time for us to take decision on how we want to roll that. So it's time for us to actually move on. Thank you. Thank you.
Thank you. And maybe to close, just in 1 minute, there are two words that we feel are very important here as well. I want to go back on 10 years ago. Amazon came up with a patent, which is super interesting, that I encourage you to look at. It's about anticipatory sales analysis. And the aim is super simple. You know, now the recommender system of Amazon is kind of so-so, to the extent that maybe all the products you get is not something you want to order. But let's imagine a world where you have all the data about yourselves, and I can then ship a good at your place before you think about it, because based on all the data I have, I know what you need. And that's the patent that Amazon released 10 years ago. And their idea is then to try and move from a classic shop and ship approach to a ship and shop type of business paradigm. And we feel we're at the beginning of this with OPmobility and the industry. That's the classic paradigm that we have in the automobile industry, where we first make things and then we check if everything is all right. But by front-loading gradual insights, gradually front-loading insights that come later at the decision-making sort of information chain, from the testing, from the manufacturing, from the simulation, and this is what we're doing here, simulation to the designer, front-loading to the designer. We hope that very soon we can, with you, switch from a make and check type of paradigm to a check everything and make it first time right. So thank you very much for your attention. Yeah.
Thank you, Nicolas.
Thank you. Maybe I had
So I'm not sure, do we still have time for questions or not? I can see we're, no? So you're the timekeeper, so you decide.
Yes.